Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 4 in the directory traversal module titled File Path Traversal, Traversal Sequences Stripped with Superfluous URL Decode. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Go down, select the learning path, go down again, select directory traversal, and then go down one last time until you reach lab number 4 titled File Path Traversal, Traversal Sequences Stripped with Superfluous URL Decode. Alright, let's get started. This lab contains a file path traversal vulnerability in the display of product images. The application blocks input containing path traversal sequences. It then performs a URL decode of the input before using it. To solve the lab, retrieve the contents of the etc passwd file. Alright, so our target goal over here is to retrieve the content of the passwd file, and the way we're going to do that is by exploiting a file path traversal vulnerability. Now there are some defensive mechanisms, so it does block input that contains the path traversal sequence, so we won't be able to use that, and then it performs a URL decode, which will become important in a bit when we do exploit the vulnerability. Alright, let's access the lab. Now notice over here, I'm using the inbuilt browser in Burp, and so all my requests are already passing through my proxy. Okay, so notice over here, the application retrieves images that are displayed in the browser, and it retrieves them using this URL. Now, whenever you see any place in the application where it's potentially accessing the file system on the server, you should definitely test it for path traversal vulnerabilities, amongst other vulnerabilities like LFI or RFI. So we're going to send this request to repeater and test it there. Okay, so if you hit send right over here, you could see it's a 200 OK response, and it displays the content of this file right over here. So the first thing that we're going to do is see if it accepts any absolute paths. So etc/passwd, hit enter, and it says no such file. So the next thing we're going to do is see if it accepts us getting out of that directory. So using the path traversal sequence, which we know it's not going to accept based on the description of the lab, but let's try it. Okay, we get no such file. Next, we're going to see if it allows us to bypass that defense using the technique that we learned in the previous lab. So if it non-recursively checks for that sequence, hit send, and it does not. So the next step that I'm going to try is remove that bypass technique and then encode it. Sometimes when it's encoded, the application checks for that sequence on the encoded text, which obviously is not there because it's encoded, and so it allows us to bypass the defensive mechanisms that are in place. So I'm going to say URL encode all characters, hit send, and we still get no such file. And the reason is because, as the description listed, it actually decodes it, and then it blocks any instances of the path traversal sequence. And so let's encode it again. So convert selection, URL, and then URL encode all key characters, hit send, and see if that works, and it does. So you could see over here, it dumped the content of the passwd file, and if we go back to the application, it says, congratulations, you solved the lab. So the only reason this worked is because it only decodes it once, and then based on the first decoding, it checks for that sequence. But if that was the case, this is what the backend is doing. So convert selection, and then URL, and URL decode. So it's decoding it once, and then it's looking for this sequence right over here, and it doesn't find it because it's encoded, and so it bypasses their weak defense mechanism. Alright, so we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. And before we do that, let's return this to the original exploit that did work. Okay, so this should be relatively simple because, again, it's an unauthenticated exploit and it's only done using one request, so the script shouldn't be too long. the first thing that we're going to do is import the libraries that we need. So the sys library, the requests library, and the URL lib3 library. Next, we're going to disable and secure request warnings. So URL lib3.disable warnings and URL lib3.exceptions.insecure request warning. And then we're going to set our proxy settings so that all the traffic is sent to burp. So we're going to say HTTP traffic. That should be sent to burp, which is running on HTTP 127.0.0.1, port 8080. And then same goes for HTTPS traffic. That should be sent to HTTP 127.0.0.1, port 8080. Okay, this looks good. Next thing to do is define our main method. So if name is equal to main, and that should be in quotes, then call the main method, and we'll define the main method right over here. So the main method essentially ensures that the script is run correctly and then calls another function that performs the exploit. So the first thing that we're going to do is we're going to check the number of command line arguments. And if it's not equal to 2, that means the script wasn't run correctly. And so we're going to print a statement listing the usage instructions, which is the name of the script, and then the URL of the vulnerable application, and the name of the script we take from the command line argument. Next, we're going to print example instructions. So example, again, the name of the script and an example URL. So let's just say www.example.com. And the name of the command line and the name of the program is taken from the command line argument. Okay, and then we're going to exit the program because it was run incorrectly. All right, this looks good. So it'll enter this if clause if the user runs the program incorrectly. If the user does run it correctly, the first thing that we're going to do is create a variable called URL and set it to the second command line argument. And then we're going to print a statement saying that we're exploiting the directory traversal vulnerability. And to do that, we're going to call a function called directory traversal exploit. And it takes in the URL of the application. All right, this looks good. Now let's define our custom function. So def directory traversal exploit, again, takes in the URL. And the first thing that we're going to do is create a variable called image URL, which is the URL to the vulnerable path. So that would be the main URL of the application, plus this entire path right over here. So let's copy that and put it in quotes. And then it's as simple as performing our request. So R is equal to request.get, and we're saying .get because it is a get method right over here. And so it takes in the image URL that we just defined. We're going to set verify to be equal to false because we don't want to verify TLS certificates. And then proxies to be equal to proxies because we want the request to be sent to burp. And I want to verify that my exploit worked. And the way I'm going to do that is I'm going to check for this string right over here in the response of my request. If that string is available, that means my exploit worked. If it's not available, that means my exploit did not work. So I'm going to say r.text. And if I find that string, I'm going to print exploit successful. I'm also going to print the following is the content of the passwd file. And I'm going to dump the content of the file by simply just dumping the response of the request that I just made. So it'll dump this portion right over here, which is the content of the passwd file. Okay, this looks good. Now this assumes that my exploit worked. Now if my exploit did not work, I'm going to print exploit failed. And I'm going to exit my program and save. All right, so let's review the program. In the main method, we first check if the program is run correctly. If it is run correctly, then it'll call the function directory traversal exploit. This function is responsible for performing this request and exploiting the path traversal vulnerability. If the path traversal vulnerability is successful, then it'll dump the content of the passwd file. Let's see if we have any errors in our script. So terminal, new terminal, and then Python 3, directory traversal lab04.py, and the URL of the application, which likely timed out, and it did. So let's open it again, copy that, put it in here, hit enter, and here we go. It says the exploit was successful, and then it dumps the content of the passwd file. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at a more complex case of path traversal vulnerabilities or directory traversal vulnerabilities.